Hello everyone, I'm Ümit Alkuş. In this video, we will solve one problem from chapter 22. A positive charge Q is uniformly distributed over a rod of length 3a. Find the x and y components of the electric field produced by the rod at point P. At a distance x to the origin, in a thickness dx, we choose a differential element dq. Since the charge is distributed uniformly, the charge density lambda is found as q over 3a. Or in a differential form, it is dq over dx. From this, we obtain a formula for dq as capital Q over 3a dx. The point P is a distance r equals square root of L squared plus x squared to the dq. Since the charge of the rod is positive, we think that as if there is a positive charge at P, then the differential electric field is drawn like this. The magnitude of this differential electric field is k times dq over r squared. dq is capital Q over 3a dx, and r squared is x squared plus L squared. From the right triangle, sin theta is x over r. Here r is square root of L squared plus x squared. And cosine theta is L over r, then L over square root of L squared plus x squared. After that, the x component of the differential electric field dEx is dE times sin theta, and the y component of the differential electric field dEy is dE times cosine theta. The magnitude of the x component, that is Ex, is the integration of the dEx, which is dE times sin theta. dE has the form kq over 3a times dx over x squared plus L squared, and sin theta is x over x squared plus L squared to the power half. K, Q, and 3a are constant, and they can be taken outside the integral sign. Inside the integral sign, we have only the x variable. The lower limit of x is negative 2a, and the upper limit is a. One way to calculate this integral is the change of variables. Let u be x squared plus L squared. Then the limits read 4a squared plus L squared and a squared plus L squared. The differential du is 2x dx because L is constant. In the integrand, we need x times dx, which is du over 2. With this new variable, we can write the x component of the electric field as k times q over 3a times the integral with the limits 4a squared plus L squared and a squared plus L squared, and the integrand is du over 2 over u to the power 3 halves. Simplification gives us k times q over 6a times the integral u to the power negative 3 over 2 du. The integral can be taken as u to the negative 3 over 2 plus 1 over negative 3 over 2 plus 1. Or we write negative 2 over square root of u. then the x component has the formula negative k times q over 3a times 1 over square root of u with the corresponding limits. If we write the limits, we obtain finally k times q over 3a times 1 over square root of 4a squared plus l squared minus 1 over square root of a squared plus l squared. By the same way, the y component of the electric field is Ey equals the integral of dE times cosine theta. dE is kq over 3a times dx over x squared plus l squared, and cosine theta is L over square root of L squared plus x squared. As you see, k, q, L and 3a are constant and they are in the outside of the integral sign. The integral can be found in the integral table, and it is taken as x over L squared times square root of x squared plus L squared, and the limits are negative 2a and a. If we put the limits, we get kql over 3a times a over L squared square root of a squared plus L squared minus negative 2a over L squared times square root of 4a squared plus L squared. A's cancel each other and L's cancel each other. Finally, the y component of the electric field produced by the rod at point P can be written as k times q over 3l times 1 over square root of h squared plus l squared plus 2 over square root of 4a squared plus l squared. So that's enough. Thank you for your attention. See you on the next video.